Hey everyone, so today I want to walk you through something that changed how I work on my machine learning project. So I'm working on a project which is called Trust ECG. Basically what I'm trying to do is I'm building a model that looks at an ECG recording of someone's heart and tells you what's going on. Is it normal? Is there a heart attack happening? Is there some kind of blockage or conduction issue? The dataset I'm using is called PTB-XL. It's a huge open source dataset from PhysioNet, around 21,800 ECG recordings from real patients. Each recording is 10 seconds long, sampled at 500 times per second across 12 leads. Now, if you're not familiar with ECG leads, think of them as 12 different angle views of your heart's electrical activity, all recorded at the same time. Different leads show different parts of the heart. And my job is to classify each one of these recordings into one of 5 categories. Norm, that's normal. MI, myocardial infarction, basically a heart attack. STTC, which is S, T segment, and T wave changes. CD, conduction disturbances. And HYP, hypertrophy, where the heart muscle is thickened. Now, the way I was doing this before was everything in Python scripts. I had a script to convert the raw ECG files into Parquet format using WFDB and pandas, a separate script for plotting, another one for trying out different pre-processing steps. And every single time I wanted to change something, say, adjust my bandpass filter from 0.5 to 40 Hz to maybe 1 to 35 Hz, or try z-score normalization instead of min-max. I had to go into the script, find the right line, change it, and rerun everything. Now that sounds like a small thing, right? But when you do it 20, 30 times in an afternoon, it gets really frustrating. And it's easy to lose track of what you actually tried. Did I already test order -3 filter? Did I apply normalization before or after resampling? I'd forget. Labeling was the other big pain point. I was using matplotlib to plot the ECG, manually picking a start time and an end time on the graph, writing those down, adding them to a CSV by hand. For 21,000 records, that's not going to work. So I started looking for a better tool, something that would let me explore the data visually, adjust preprocessing runtime, and label things without writing a new script every time. And that's when I came across dFL, Data Fusion Labeler, made by Sofilio. It's a desktop application, runs locally on your machine, which is important for me because I'm working with patient data and I don't want it going anywhere. Okay, so the first thing I had to do was write what dFL calls a data provider. It's a short Python script, basically just telling dFL where your data lives and how to read it. I had already converted my PTB-XL files into individual Parquet files, one Parquet file per ECG record, named something like ECG_00001.parquet, ECG_00002.parquet, and so on. The data provider script just says, here's the folder, here's the column names, time_s for the time axis, and 1, 2, 3, AVR, AVL, AVF, and V1 through V6 for the 12 leads. And that's basically it. I go into dFL, click Settings, open the data source, point it to my provider script, and all 21,799 records just appear in the dropdown on the left side. I just pick a record and it loads. All right, let me grab record ECG_00001. I just select it from the dropdown on the left, and now I can add my signals to the graph. I'll add all 12 leads, 1, 2, 3, AVR, AVL, AVF, and then V1 through V6. And there you go, a proper 12-lead ECG waveform. You can see the rhythmic pattern, the P wave, the QRS complex, the T wave, all clearly visible across all 12 channels in one view. I can switch between records and the layout stays exactly the same. I just look at the new data in the same structure. But the layout I prefer is the clinical 3-panel setup. Cardiologists don't usually look at all 12 leads crammed into one graph. They split it. So I set up graph 1 with the limb leads 1, 2, and 3. Graph 2 has the augmented leads A, V, R, A, V, L, and A, V, F. And graph 3 has the precordial leads V1 through V6. This mirrors exactly how you'd see an ECG printout in a hospital, and it makes it much easier to spot patterns specific to different regions of the heart. I can switch between records and the layout stays exactly the same. I just look at the new data in the same structure. Okay, so here is the part that genuinely made me stop and go, there's this panel called Data Customizations, and what it lets me do is apply pre-processing steps, fill missing values, resample, normalize, smooth, all from the UI, and see the result on the graph immediately. So let me show you. I'm on ECG_00005 right now. Let me go into the Data Customizations panel. I'll set Fill NANS to interpolate so any missing data points get smoothly filled in. Then I'll set Normalizing to Z-score. And here's the big one, smoothing. I have a custom filter I wrote myself called Trust ECG Butterworth Bandpass. It's a Butterworth bandpass filter between 0.5 and 40 Hz, order 2 at 500 Hz sampling rate. I registered it in my provider script, and it shows up right here in the dropdown with all my parameters editable. Now I just hit Apply Data Customizations, and the graph updates live, right in front of me. The baseline wander is gone, the QRS complex is clean and sharp, exactly how I want it for training. I want to try Z-score versus min-max normalization. I just switch the dropdown and hit Apply again. Different filter order, change the number, hit Apply. I can compare what different pre-processing does to the signal. In my old Python workflow, each one of those changes was a full script rerun. Here, it's just click. This is the single biggest time saver for me. Now let's talk about labeling. This is the other thing that used to take forever. I switched to record ECG_00003. I turn on Label Selection Mode from the panel on the left. Now I can just click on the graph to select a time region. I click once for the start, once for the end, and a region gets highlighted. For this clean section here, normal heartbeat, no issues, I select it, choose Norm from the label dropdown, and hit Confirm Label. Done. Now let me pick a different region. Let's say this part here where I can see some ST elevation. I select it, choose MI this time, confirm. Both labels are now in my current labels table right here in the sidebar. I can see the time range, the label name, everything. And when I'm done with all my records, I just click Download Labels. It saves a CSV with all labels across all records. That CSV is what I feed into my Trust ECG training pipeline. Another interesting feature I am using is auto labeling as the dataset is large, so manual label is bit time taking, so using auto labeling is pretty effective. Okay, after everything, I'm ready to actually train the model. I export from dFL. It gives me a CSV per graph, so time column plus the lead data, and a JSON metadata file that records exactly what pre-processing I applied, what parameters I used, when I exported. We can load the CSV via Pandas and do training via PyTorch or TensorFlow. So that's the full workflow. If you're working with any kind of time series data, ECG, EEG, sensor data, or whatever, and you're still doing all this manually in Python, I genuinely recommend giving dFL a try. I'll put the link in the description. That's it. Thanks for watching.